Okay, this is the division with complex numbers, or dealing with reciprocals. First, what we want to talk about is a little recall thing. Okay, what was the value of I? Well, that was the square root of -1. What was I squared? Well, that would be -1. I cubed would be -I, and I to the fourth is just +1. So these are called the cycles of I, and that enables us to quickly evaluate I to whatever power we need to. The very easy thing to do is just divide your exponent by 4, and the remainder tells you which of these 4 your value of I is going to be. So what does a complex number look like? Well, it is simply A plus BI. So we have a real part with A and an imaginary part with BI. Okay? Conjugates look exactly like A plus BI, except they have a different sign. Okay? So we might have A minus BI. Okay? Now conjugates are useful. If A minus BI is our conjugate for A plus BI, look at these. They have the same terms but different signs in the middle. Okay? Conjugates are very, very useful. Okay? We saw conjugates back when we did factoring. We had like x minus 2 times x plus 2. Same terms, different sign in the middle. Okay? And when we multiplied these, we got x squared minus 4. So that made our middle term disappear, which was nice. And the effect that it has with complex numbers is also quite interesting. Okay? Now, remember that 1 times any number is just itself. So if I have a creative form of 1 that serves the purpose of not changing the value of something when I multiply it, but also changing its format, then that becomes useful. So we're going to do this so we can create common denominators. Okay? So when we divide complex numbers, we're going to use conjugates. What we're going to do, let me scroll in a little bit here, is we're going to multiply this fraction times a conjugate of the denominator, so 4 plus 5i, over itself. Now, let's multiply the bottom out first. So we have 4 minus I times 4 plus I, and that is going to give us 16 minus, or plus 20i, minus 20i, minus 25i squared. Well, my 20i and my negative 20i go bye-bye. They cancel each other out. And negative 25 times I squared, remember I squared is -1, just becomes 16 plus 25, which 16 plus 25 is going to be equal to, let's see, 16 and 25 is 41. So we've completely eliminated I from our denominator by multiplying by a conjugate. Okay? And that is always going to happen. When we were rationalizing denominators of square roots, we multiplied by the square root over itself, and that eliminated the square root. So we have the same concept here with multiplying by the conjugate over itself, because the conjugate multiplied by its pair has the effect of getting rid of the complex number. Now, we still have to multiply the top times the conjugate top. So that's going to be 8 plus 10i plus 12i plus 15i squared. And again, this is taking the value of -1, so we have 8 plus 22i minus 15. And 8 minus 15 is -7 plus 22i. So we've completely been able to get the complex number out of the denominator. And this is the result that you get when you divide two complex numbers. It's still complex, but you don't have any complex numbers in the denominator. Okay. Recall what a reciprocal is. What's a reciprocal of 3? Well, that's 1/3. And what's the reciprocal of 1/3? 3. You remember you just flipped the fraction, so 3 over 1 is just 3. Well, what's the reciprocal of 2 plus 4i? And that's just going to be 1 over 2 plus 4i. Okay? So, we want to express 1 over 2 minus 3i in terms of a plus bi. And remember, we don't like complex numbers in our denominator. So I'm going to take 1 over 2 minus 3i and multiply it by the conjugate over itself. So 2 plus 3i divided by 2 plus 3i. So the top is just going to be 2 plus 3i. But the bottom is going to be 4, and my middle terms cancel out, minus 9i squared. So that's going to be negative 1. And that is going to be 2 plus 3i over 4 plus 9, which is 13. Okay? So 1 over 2 minus 3i is just equal to 2 plus 3i over 13. Here we have a situation where we want to add two fractions, and they each have different denominators. So we need to have them have the same denominator before we can add them. Okay? Now these are conjugates of each other, so when we build up the denominator, it's going to be a little bit interesting. So my common denominator is going to be the product of these two denominators. So 1 over 2 minus 3i will get multiplied by 2 plus 3i over 2 plus 3i. And then 1 over 2 plus 3i will get multiplied by 2 minus 3i over 2 minus 3i. And that will get us a common denominator. It's just like if you have 5 and 7 as your denominators. You know your common denominator would be 35 because you multiply 5 times 7. So, tackling this first area here, we'll have 2 plus 3i all over 4 minus 9i squared, which is just going to be 2 plus 3i over 13. Our next one is going to be 2 minus 3i over, and it's the same denominator, so over 13. So plus 2 minus 3i over 13. So now we have just 2 plus 3i plus another 2 minus 3i all over 13. My 3i's cancel out, and I'm left with 4/13. So if I add the reciprocals of two conjugates, I'm adding two complex numbers and getting a real number. Kind of interesting.